Good morning, students. So today's class we are going to study about a design of ideal high pass filter whose frequency response it is given by h3 of e power j omega equal to 1 for pi by 4 less than or equal to modulus of omega less than or equal to pi, and 0 for modulus of omega less than or equal to pi by 4. So the given problem is you need to find out the h of n for n equal to 11 and find out h of z and plot the magnitude response using two different windows. One is Hanning window, another one is Hamming window. So using this windowing techniques, we are going to solve this problem. So first let us do it for Hanning window. You know that for Hanning window, the formula is WHN of n. It is equal to 0.5 plus 0.5 into cos of 2 pi n by n minus 1, where n varies between minus of n minus 1 by 2 to plus n minus 1 by 2. 0 otherwise. Now we have to substitute the n value 11. So if you substitute the capital value n value 11 in the formula, Hamming window formula, the formula is getting reduced to WH of n equal to 0.5 plus 0.5 cos of pi n by 5, and here when you substitute 11 it is minus pi to pi and 0 otherwise. Now for varying the n value from minus pi to pi, we need to find out the WHN of n. So if you see, we have varied the n value from 0 to 5, and according to the symmetric formula, WHN of 1 is equivalent to WHN of minus 1. Similarly for other windows, till WHN of 5 equal to WHN of minus 5. So if you substitute the n value here, you will be getting the WHN of 0 as 1, WHN of 1 value is 0.9045, WHN of 2 the value obtained is 0.655, WHN of 3 the value obtained is 0.345, WHN of 4 the value obtained is 0.0945, WHN of 5 the value is 0, and you have to keep it in mind that you have to use your calculator in degree mode itself. The next, so in order to find out the filter coefficients, HD you have to apply the inverse Fourier transform for this particular HD of e power j omega. After applying the inverse Fourier transform, so in this case you can able to see that the modulus of omega varies between pi by 4 to pi. That means omega value for positive value as well as negative value. So for positive value the limit varies between pi to pi by 4. For negative value the limit varies between minus pi by 4 to pi. Minus pi by 4 to minus pi. So using this you have to integrate it with respect to two different limits and simplify. You will be getting this expression as h3 of n equal to sin pi n minus sin pi by 4 n divided by n pi. So in this you have to substitute the value from n equal to 0 to 5. So when you substitute n equal to 0 here, it becomes 0. Then we have to apply the L dash hospital rule. Limit n tends to 0. Sin pi n minus sin pi by 4 n divided by pi n. So in this, when you apply the L dash hospital rule, according to that, first one is 1 minus 1 by 4. So which is equivalent to 0.75. Then if you substitute the n value as minus 1, you will be getting minus 0.225. N value as minus 2, you will be getting minus 0.159, and the n value as 3, you will be getting minus 0.075. N value 4, you will be getting the value as 0. For n value 5, the value obtained is 0.045. So you have to keep it in mind that if you want to calculate these values, you have to keep your calculator in radian modes. Then the filter coefficient using this Hanning window are h of n is equal to, we have to multiply the hd of n with the windowing function. For the n varies between minus pi to pi and 0 otherwise. So if you multiply that, h of 0 obtained is 0.75, h of 1 which is symmetrical to h of minus 1, the value is 0 minus 0.204, h of 2 is symmetrical with h of minus 2, so the value obtained is minus 0.104. H of 3, it is symmetrical to h of minus 3, so the value obtained is 0 minus 0.026. For h of 4 it's 0, h of 5 again it is 0. The next step, you have to apply in the transfer function of the filter. The transfer function of the filter formula is h of z equal to h of 0 plus summation n equal to 1 to 5 h of n z power minus n plus z power n. So in this place you have to substitute the n value from 1 to 5. So here we know that for h of 4 and 5 it is 0. Remaining we have the values here. So if you write that 0.75, h of 0 value is 0.75 minus h of 1 is 0.204 into z plus z power minus 1 minus 0.104 into z power 2 plus z power minus 2 minus h of 3 value is minus 0.026 z power 3 plus z power minus 3. So then in order to find out the transfer function of the realizable filter, you need to multiply the above expression with z power minus 5. So after multiplication with z power minus 5, the equation becomes minus 0.026 z power minus 2 minus 0.104 z power minus 3 minus 0.204 z power minus 4 plus 0.75 z power minus 5 minus 0.204 z power minus 6 minus 0.104 z power minus 7 minus 0.026 z power minus 8. Now in this, we have to find out the filter coefficients. So you know that h of z power minus 2, it's symmetrical with z power minus 8. That's why same value. So h of 2 equal to h of 8 equal to minus 0.026. And h of 0, it is equivalent to h of 1. H of 9 is equivalent to 10. Those values are 0. Then h of 3 is symmetrical to 7. That's why the value is minus 0.104. Then h of 6 is symmetrical to h of 8. So that's why the value is minus 0.204. For h of 5, it is 0.75. So after obtaining these filter coefficients, then we have to use this magnitude function modulus of h of e power j omega equal to summation n equal to 0 to n minus 1 by 2 a of n cos omega n. So in this, you have to substitute the n value first to 0 and for non-zero values. For n value 0, a of 0, the formula is h of n minus 1 by minus 1 divided by 2. So in this, when you simplify, it will be h of 5, the value is 0.75. Next, for non-zero n values, for a of n, the formula is 2 into h of n minus 1 by 2 minus n. So now in this, when you substitute it, we will be getting the value for a of 1, 2, 3. For 4 and 5, it is 0. For a of 1, the value is minus 0.408. A of 2 is minus 0.208. A of 3, it is minus 0.052. So after obtaining these that is A values, we have to use substitute in this formula. So in this formula, n equal to 0 to n minus 1 by 2 means 11 minus 1, 10 by 2, it is 5. For 0 to 5, you have to expand this equation. So after expanding this equation and substituting these values, you will be getting the h of e power j omega as 0.75 minus 0.408 cos omega minus 0.208 cos 2 omega minus 0.052 cos 3 omega. Now using this expression, we have to substitute the omega value varies between 0 to 180 and find out the h of e power j omega value. Also you can find out in terms of decibel using the formula 20 into log to the base 10 of h of e power j omega. You will be getting the values in terms of decibels. And also it is not required that you have to use the values of omega for 0, 15, 30 like that. You can use in multiples of 30 also. For a easier, for a simplified point of view, you can use multiples of 30. So you can use the omega value as 0, 30, 60, 90, 120, 150 and 180. For these values alone, you can find out and plot the magnitude response. So if you plot the magnitude response, this is for high pass filter using Hamming, that is windowing technique, Hanning windowing technique. So this is the final response you will be getting it. So the next one is with respect to Hamming window. For Hamming window, the formula is WH of n is 0.54 plus 0.46 cos of 2 pi n by n minus 1, where n varies between minus of n minus 1 by 2 to plus n minus 1 by 2 and 0 otherwise. So in this, you have to substitute the value of n. If you substitute the value of n, the equation is simplified as WH of n is 0.54 plus 0.46 cos pi n by 5 minus n varies between minus 5 to 5, 0 otherwise. Now in this expression, you have to substitute the value of n from minus 5 to 5. So if you substitute, we will be getting WH of 0 as 1 and WH of 1 is symmetrical to WH of minus 1. So the value is 0.912. Then WH of 2 is symmetrical to WH of minus 2. The value obtained is 0.682. Then WH of 3, it is symmetrical to WH of minus 3. So the value obtained is 0.398. The WH of 4, which is symmetrical to WH of minus 4, the value obtained is 0.1678. Then WH of 5, it is symmetrical to WH of minus 5, the value obtained is 0.08. So you have to keep it in mind that to compute this, you have to keep your calculator in degree mode. The next one. So next one is we have to, in order to obtain the H of n, we have to obtain the HD of n and WH of n. So HD of n, you know that already we have obtained the HD of n here. I think in this formula already we have obtained this HD of n. So we are going to multiply, just multiply the HD of n expression with this W of n. You will be getting for H of 0 as 0.75, H of 1 as minus 0.2052, H of 2 is minus 0.1084, H of 3 is minus 0.03, H of 4 is 0, H of 5 is 0.0036. Then the next one is we have to apply to the transfer function of the filter. So H dash of Z equal to Z power minus 5 into H of Z. So here we already find out the H of Z you substituting this formula. Then we have to multiply it with Z power minus 5. We will be getting this expression. Now after that we have to find out the magnitude response. Using this formula we obtain the H of e power j omega as 0.75 minus 0.4104 cos omega minus 0.2168 cos 2 omega minus 0.06 cos 3 omega plus 0.0072 cos 5 omega. After that, you need to plot the magnitude response. So, for different values of omega, you can use it in increments of 30 also. So, for omega 0, 30, 60, 90, 120, 150 and 180, you can find out the h bar of e power j omega values. And if you want to get the values in terms of decibel, you have to use the formula 20 into log to the base 10 of h of e power j omega. So for first value 20 into log to the base 10 of 0.07, if you apply you will be getting minus 23.1. So like that you can apply it and plot the magnitude response. This is the magnitude response which is obtained by high pass filter along with the combination of Hamming window. So you will be getting the response like this. Thank you.